Hello everyone, hope you all are doing well. Today I'm here to discuss one of the important chapter of class 6th ICSE board. This is chapter number 3 of physics, measurement. So what is measurement? What is the need of it? The measurement is actually the length, it may be the mass, time. We can measure the different physical quantities, the different materials in various units, right? That is the measurement. Now come to the basic. What is the physical quantity? The physical quantity, like this is the sheet of paper. If I want to measure the length of this paper, so this paper will act as the physical quantity. If I want to measure the length of this pencil, it is the physical quantity. So physical quantity is that a quantity that can be measured is called the physical quantity. For example, this book, if I want to measure the length of the book, that is also the physical quantity. It may be the length of the piece also, piece of the cloth or time. Anything that we can measure comes under the physical quantity. Now next is 5 main physical quantities we will discuss in this chapter. Basically 3 are the very main one: length, mass and time. About area and temperature also we will discuss in this chapter. So let's start with the first physical quantity, that is the length. What is length actually? The length is the distance between the 2 points. Like the 2 edges, it may be this one first corner and the second corner of this paper. The distance between these 2 points is the length. It may be the between the length of the corners of the 2 rooms, or the length of the curtain from top to the bottom of it. So length can be of anything. If we measure the distance between the two towns, and we are saying the distance it is, but it is also actually the measurement of the length. So various things in our daily life we are measuring in the form of the meters, kilometers, centimeters and millimeters, all comes under the measurement of the length, whether we are using the different units. What are the units? That we will discuss further in this chapter only in detail. Now let's come to the next topic, that is the mass. What is mass now? This is the property of the physical body, that is actually the matter contained by the body. That is the mass. The amount of matter, how much one body is containing, that is the mass of the body. Now in our daily life, what we are saying, we are using the term weight. How much weight of this particular person or anything, right? That we are talking about the weight in our daily life. Now one very important thing, that mass and weight both are the totally different physical quantities. Now how and why they are totally different physical quantities? Because weight of the body is just because of the pull of the earth, that is the gravitational pull. Earth is having gravity, we all know. So it is applying one attractive force on a particular body towards itself, that is the pull towards the earth, which increase the mass of the body. So when the gravitational effect, that particular pull, the force is added to the mass, it gives us the weight. So weight is equals to mass of the body plus the gravitational pull. When we are talking about the mass, it is only how much matter the body is containing. I hope this is clear. Now come to the next topic, that is the time. For time, there is no any particular specific define. What is time actually? It is the measurement of the distance, any particular time interval maybe, or it is the particular time of the day, like at which time you are going to the school, that is the time. And the time taken by the athlete to complete the race, that is the time taken. Time in detail we will discuss further in this chapter with the help of some examples. Next is time we can measure in the different things, like 1 day, 1 year, 1 month, that all comes under the time. It is actually the measurement of the time. Like if we are saying to someone that I will come back in 1 hour, that is also the measurement of the time. After how much time I will come back. right? Now we are taking the example of the sun. Like sun is here, earth is revolving around the sun, and moon is revolving around the earth. Moon is taking some time to complete the one revolution, that is approximately 29 days, and earth is revolving, it is taking 365 point some days to complete its one revolution, and earth is completing the one rotation around the one axis, that is in the one day, right? So these all are also the measurements of the time. Clear? Next is area. Now what is area? Area is basically only for the closed figures. Like we are finding the area for the rectangle, not for the line. We are finding the area for the square also, for circle, triangle, for different 2D figures as well as for the 3D figures. 3D figures like for cuboid also we are finding the area. So area is only for the closed figures which are having the closed lines. Now what are the closed lines? This concept we have done in the lower classes also. Closed figures and the open figures are there, right? What are the closed lines? Which are having the fixed starting and the end point. Open figures are those which are having one starting point and the end point is at the other corner. They're not meeting each other, so the figure is opened. That are the closed figures, right? The next fifth is the temperature. Now what is the temperature? The temperature of an object is the measure of its degree of the hotness and the coldness. If we talk in general, we are having a glass of water. One is the hot glass of water, second is the cold glass of water. Just after touching it, we can sense that this glass is containing the hot water and the other glass is containing the cold water, the cool water inside it, right? So that is actually what? That is the sensation of the hotness or the coldness of any particular body. This is because of the particular measure of the degree, particular measure of the temperature for the body is different. That's why we are experiencing the both things as a different one. That is the temperature. Like in summers, the temperature is more. In winters, the temperature is lower. Right? The next is the measuring of physical quantity. Now we come to know the various physical quantities. Till now we have done the mass, length, time, area and temperature. These 5 physical quantities till now we have done. Now how to measure the physical quantities with the help of the unit. Till now we know what is the physical quantity. Anything we want to measure in any of the unit in the form of the length, we want to measure its weight, time taken or time, that all comes in the measurement of the physical quantity. Now for this, one very important thing is required, that is the unit. Now how to select the unit? Suppose we are taking the length of the room, right? That is in the form of the length. So we can take the standard length to compare the length of the room. That is the 1 meter we can use, the meter rod we can use, or the measuring tape we can use to find the length of the room. So it means how we are finding the lengths or the measurements of the physical quantities. Firstly, we are choosing a particular unit. Like if I want to find the length of the room, I can use the meter tape. In that meter scale also I can use. These things I can use, right? If I want to find the length of this pencil is the physical quantity then. So I can easily find the length of this pencil by using the centimeter scale, that is the ruler, right? So it means we have to choose that physical quantity with which we can easily compare our physical quantity to measure it. Same is the define of the unit. What is the unit and how we have to choose the unit? That is, a unit is the known measure of the physical quantity. Known measure of the physical quantity means, like here the known measure is the 1 meter, or the ruler that is having the 15 centimeters, right? On the normal smaller scale we are having measurement up to the 15 centimeter. So that is the known measure, means we know that it is of how much particular measurement long it is. So let's read again. A unit is a known measure of the physical quantity with which the physical quantity of the same nature or same kind are compared. The centimeter scale and the pencil both are of the same approximately equal lengths. So I can easily find out the measurement of this pencil with the help of the ruler, with the help of the scale. So I am taking here the same kind to compare the lengths of the both physical quantities. Now next is, before finding the length of any physical quantity, we need the two things. What are the two things? One is, we know the physical quantity. If we have the physical quantity, if I found the length of that physical quantity, just assume here I'm having the room and I found the length of the room, that is 5.4 meters, the one length of the room. Okay, after that you can see here there are two things in this measurement. One is the numerical value, that is n, and the second is u. What is the u here? That is the unit, which is meter here. So these two things combinedly, the numerical value and the unit, these two things combinedly gives us the physical quantities measurement. That is the measuring of physical quantity. I hope this is clear. And what is unit, how to choose the unit, that is also clear to everyone. Next is, for the measuring anything's length, like meter is the SI unit for measuring length, we are having some smaller unit and some larger units of length. Kilometer is the larger unit of length, and the centimeter and millimeter, these two are the smaller units of length, right? Now the centimeter, meter, and these all things are also units of length, so we particular represent these all things as the units of the length. Now one very important thing here, that is the multiples and the submultiples. What are the multiples and submultiples? That I will explain you in the metric system topic along with some examples. Now come to the next topic, traditional methods. What are the traditional methods now? Like in the ancient time, persons are using their body parts to finding the length of any particular thing, right? Like this is the hand span. With the help of the hand span, the person used to find the length of the various objects or materials, right? But all are not having the same body parts length, like all the individuals. So everyone's body parts are also having the different lengths, right? Some are having the larger height, some are having the smaller height. So according to it, all are not having the same length of their hand also. If one person is measuring that any board, any particular blackboard or white green board is of like assume 7 hand span, right? And another person is also finding the same. Another person is saying that it is of the 6 hand span. The value is not same. There is a difference between the value. So it means this is because of that. This is not the standard way to measure any of the thing. That's why. Now these methods of measuring the various things are known as the traditional methods, which were used in the ancient times for finding the length or anything, to just take the estimation of the length of the material, of the physical quantity. Now these are considered as the non-standard units. That's why we needed to just replace it with the standard units. Now what are the standard units and what are the main properties we need in that standard units? Let's focus on that now. There are the 3 main properties written here. The use of the non-standard unit lead to many problems. That's why some experiments come yield that different results in the different parts of the world. To avoid such problems, we need the set of the systems of the standard units, which has the following characteristics. It means now what we are going to do, some of the properties, some of the characteristics which a standard unit must obey, then it will be considered as the standard unit. Because these earlier the traditional methods were the non-standard methods, or they are giving the non-standard units, right? Because they are giving the different results in the different parts of the world or different cities or different places, right? First is, the system of units should be used everywhere. Just like we are using the kilogram for measuring the weight, like we are going to the market to buy some vegetables or other things, but we are saying, we can say that just give 2 kg of carrot, like this we are saying. So it means it can be used everywhere. Here also, at the place of our relatives, anywhere we are going, it is used everywhere, right? Second point is the units should be precisely defined and have the same value everywhere. Like if the 1 meter is of this much length, the 1 meter will remain same of this length only at every place. Second point is also clear. Come to the third point now. The unit should be of the convenient size. Convenient size means, now there are the two meanings of the convenient size here. One is so that it can be easily portable, means from one place to other we can easily just take it along with us to measure the different materials. The second perspective of this case is of the convenient size is, like if I want to measure the length of the pencil, of the distance I want to measure between the two towns, units must be that which I can use easily, which can easily be comparable to the physical quantities. For example, here, if the mile were only unit of the length, it will be very inconvenient to measure the small lengths, just like the length of the pencil. It will become very inconvenient. That's why the unit's size must be of the convenient, so that we can easily use it everywhere and anywhere. The next is, now we are going to study the three different systems of the units which are as the standard system of units. First is FPS system. What is the FPS system now? Before starting the FPS system, I am going to tell you something about the SI system. Okay, SI system is the standard system of units which is widely used everywhere in the world. About the 5 things we have to talk in this chapter. First is about the mass, then length, then time, then area, then temperature. Right? These are the 5 things. Now, I'm going to tell you about the SI units of these 5 things firstly. Then we will discuss about the FPS system. What is the FPS system? It will be easy for you to compare and to learn by comparing it with the SI system. First is the mass. The SI unit of mass is kilogram. And for length it is meter. For time it is second, and for time it is, in all the system it is second. Next is area. What is area? Let's say the area of rectangle is length into breadth. Both are the measurements of the length. It is meter into meter, then it is the meter square eventually. Temperature. The SI unit of temperature is Kelvin. But we are using mostly the degree Celsius or degree Fahrenheit. But the SI unit is Kelvin actually. Okay, hope this is clear. These are the standard units in which we are measuring the different things, and this is a systematically international system of units which is acceptable everywhere, even internationally, worldwide, all over the world. Okay, now what is the FPS system? The FPS system actually even started in the British countries and in the British rule actually, like in England. This is also a British country. So there it started in the middle 20th century it started. Nowadays also it is still in use in the English speaking world countries, but it is very rare used nowadays. In very few parts it is used. The second thing is, even in India, but still at the some of the places in some of the works, this FPS system is widely used. Like the tailors are using, the carpenters are using this, right? Now, what is the full form of this system? Just like in the SI system, these are the units, standard units. Okay, if we come here, the mass, length and time, these are the 3 things, and I want to tell their FPS units instead of the SI. Now from the name of the system, what is the first? First is the foot. Foot is used for the length and its symbol is FT. Pound is used for measuring mass with the symbol LB. Second is used for measuring time with the symbol S. So F for the length, pound for the mass and S for the second, that is for the time. This is the name, and how it is classified from the name. Is it clear? Then the next is, in the later 20th century, this system is not more used in the case of the scientific areas. Why? There are three or several reasons behind it. Because of the ununiformity of the system, that's why. The first major reason is that because sometimes the unit of mass, the pond is acting as the unit of mass, and sometimes it is acting as the unit of force. That's why. The second is, it is not used all over the world. It is just used in the English speaking countries, in the British ruler countries. And the third main reason is, it is very difficult to convert the units into larger and the smaller units and vice versa. That's why these units and this system was not accepted that time. Here the same each and everything about the FPS system is mentioned in the form of the table. Now we are going to do the second system of units, that is the CGS system of units. In the CGS system, just like the FPS, the name is showing and representing each and everything about the system of units. C is representing the centimeter, which is the unit of length. G is for the gram, which is the unit of mass. S is for time. So same the table is representing. This is also just like the FPS system. These were used widely in the British ruled countries, but it is nowadays very less used in the scientific work. Still, but it is used, but not that much large. Why not that much used? Because the smaller units sometimes are inconvenient. But sometimes we need the smaller units. That's why this is used in the scientific work still, but the unit of the system are too small to be convenient sometimes. That's why it is used, but rarely. Next is the metric system. This is the third system. The metric system is similar to the SI system. In the metric system, it was developed in the France near the 18th century, and the unit for this are the length, mass, and the volume. In the system, the meter, gram, and liter, these were the three respectively. Respectively means for length it is meter, for mass it is gram, but for the SI it is kilogram. Volume is measured in the liter respectively, means first is for first, second, then third. The metric system is the logical convenient system for the following reasons. Why? Means what were the advantages of the metric system? Why they were accepting the metric system? The two main points are given here in your book. The first one is, a physical unit is defined for each physical quantity such as the length and mass. Whichever unit we are using, it must be convenient for any of the physical quantity. Just like if we are taking the length, or if we are taking any of the physical quantity, like physical quantity, I'm taking the book, I'm taking any table, that is measured in the form of the length and mass only. That can be measurable in the form of the length and mass only. So it means any of the single unit and is used or defined for the physical quantities to measure it. Okay, next is, the larger or the smaller forms of a unit are related to each other by the powers of 10. Means just like we know that 1 kilometer is equals to 1000 meters, or I can write it as 1 kilometer equals to 10 into 10 into 10. 10 tens a 100, 100 tens a 1000. It will give me the same back this. Or I can write it 10 raised to power 3 meter also. Why? Because what is the meaning of this? It means that 10 is multiplied by 3 times, not 3 into 10. This is wrong. It means 10 is multiplied 3 times. Means 10 into 10 into 10 it is. So you can see here, what is this? This you will study in the maths in the next class. This is the power of the 10. So same is written here. Larger or smaller forms of unit are related to each other by the powers of 10. This is more explained in the form of a table which is given below. Firstly, let's see what are the multiples and the sub-multiples of the unit. See here, it is the m written, that is denoting meter. Next is the centimeter. Next is the millimeter I am writing. And to this side it is kilometer I am writing. This is the standard SI unit in the center. These two are the, we know, the smaller units. And this is the greater unit, right? This is the greater unit. Now, the smaller units are giving the smaller values, smaller measurements. Just assume if I am dividing the 6 with the 3, it is giving me the smaller value 2. So these are giving me the smaller values, means these are actually the sub parts of the unit, this. So if these are the sub parts, these are actually known as the sub multiples of the unit. These are known as the sub multiples of the unit. Now this is giving the greater value. Greater value means if I'll multiply the two numbers, it will give me the greater value. So greater value I'll achieve only after multiplication. So this unit is known as the multiple of the standard unit. So these are the multiples, these are the sub-multiples. Sub-multiples which are subdivided, which are the sub-parts giving the smaller values, and the multiple is that which is giving the greater value. That's why it is known as the multiple. Just like after multiplication we are getting the greater value. So this is used for the greater measurements of the distances or of the lengths. Is it clear? So come here back. Multiples and sub-multiples of the units are clear to everyone? Sub-multiples are the smaller ones and the multiples are the larger ones. Now we know we are writing the meter as this, kilometer as this, centimeter as this, millimeter as this. You can see here before meter I'm writing a letter, an alphabet here. These are the prefixes. This is also prefix, this also and this also. So these are what? These are the prefixes written here having their symbols, these, which we can write in the form of these factors also. As I told you earlier that 1 kilometer we can write as 10 raised to power 3 meter. So kilo, it is 10 raised to power 3. Factor of what? This is the factor of meter. After comparing these things, these prefixes with meter, how much power they are getting, it is written here. Just like the kilometer, you can solve these also and check easily. Next, come to the next part of this topic, that is, let us consider the meter, which is the unit of length in the metric system. In the metric system, for length, which unit we are considering? They said we are considering the meter. All the lengths or the distances can be expressed in the multiples and in the sub-multiples of the meter unit, right? So they are giving now few of the examples of the multiples and sub-multiples. The first example is what? Larger distances, like the distance between the towns, we can measure in the form of the kilometer. Now what is the relation between the kilometer and the meter? It is 1 kilometer equals to 1000 meters written. Next is for the smaller lengths, just like we are using centimeter, we can use the millimeter also in comparison with the meter, right? If we want to measure the thickness of the pencil, length of the eraser, then we can use the centimeter value also. Now 1 meter is equals to 100 centimeter. So this is in the form of the multiplication with the centimeter. See here, like 100 into 1 is also 100. So can I write this 100 as 100 into 1? Here 1 meter equals to 100 into 1 is the centimeter. Okay, just like in the lower classes and in maths also, you have learned that the addition is changing into the subtraction and the subtraction is changing into addition. How? When we are changing the sides of the numbers from one side of the equals to the other side. Just take an example. 2 plus 3 is equals to 5 is here. If I want to shift this 3 to other side, it will change the sign because I am shifting to the other side of the equals to this 3. It will move along with the sign, and the sign will change as it will pass away from the equals to. If it is in the negative form, I want to shift it again to that side. Its sign will again change from minus to plus. From plus to minus it changed. This is in the form of the addition and subtraction. The plus is changing to minus and minus to the plus. Now in the case of the multiplication and division, the multiplication is changing into division and the division is changing into the multiplication. Just like these are two opposite to each other, These two are also opposite to each other. Okay, so here this is in the form of the multiplication with 1 centimeter. It will come to divide, multiplication to divide. So 1 meter I can write as 1 centimeter equals to 1 by 100 meter. This in the form of the decimal I can write as this. This value, how it comes now, same like here. That is 0.01 meter is equals to 1 centimeter. Same I found here, 1 centimeter equals to this value. Now 1 centimeter equals to 10 millimeters. So I can change this value with the millimeter also. If I will change the centimeter into millimeter, this 10 will go on division here this way. The point will shift with 1 digit more because of 1 0. So answer will come 0.001 meter is equals to 1 millimeter. Same is written here. 1 millimeter equals to this value. I hope this is very clear. Otherwise you can just go back and just listen the video again carefully. The next is for very small thicknesses, just like the thickness of the air. It is measured in the micrometers. 1 micrometer is equals to this value. This you will study in detail in the higher classes. Next is the SI system of units. The main thing is what is the full form of the SI units. That is the system international units, and these are accepted everywhere. These are also known as the base units or the fundamental units. These are actually the 7 quantities. 7 base units are there, 7 fundamental units are there. But here in your syllabus we are studying only 5. Still only 4 are written here. The main are 3 only. Out of 7 in your syllabus 5 are there, 4 are written here. And the 3 are the main one, which are these 3. Mass, length and time. Same this thing we have already discussed here. What are the SI units for the different physical quantities? Same is written along with the unit, symbol and the quantity in the table. This you can check easily. Next is I made you clear about the area also, how we can find the area. Same this thing is explained here. How we can find the volume, this is explained here. Volume, how we can find? Volume of the cuboid is length into breadth into height it is. All these 3 are the measurements of the meter of the distance. So we can write it as meter cube. That's why after multiplying all the meters for the volume, which units we are getting? This is the meter cube. I hope this is clear. The next topic is very important. That is the writing units correctly. What are the various ways of writing the units properly, correctly? 3 points are mentioned here. 2 are at the next page also. Yes. What are the 3 points? The first thing is, let's discuss and learn these with the help of the some examples. For example, the first thing is written, if the unit is named after the person, we use the small letters for writing the full name of the unit. Just like Kelvin was one scientist, and we are having the unit also named as the Kelvin for the temperature. Okay, so we are having to write the Kelvin by using all letters small even first also. This is the right, this is wrong. Clear? Second is, if the unit is starting from the person name, after the name of the person, if we are giving the symbol for it, then we have to use the capital letter. For the same Kelvin, if I am just writing the symbol, then capital letter is accepted, not the small. This is wrong then. So it means for writing the full name of the unit, use the small letters. For writing the symbol only, use the capital letter. The third point is, when we write units which are named after the persons, we use the small letters for the units and their symbols. For example, if they are not named after the persons, note this thing here, then we are using the small letters for the symbols and for the units also. Means We are writing the meter complete also small and the units symbol also as the small. Meter also small and its symbol both as the small letters. What is the next point now? The next is plural form of unit is used when it is written in full. Means if it is written like this, meters, then we can use the plural form. If we are writing only in the form of the symbol, then we can't use the plural form. We can't write it as meters like this. This is wrong. This is right. And if we are writing full, then only we can write the S at the last. The fifth point is, this is clear to everyone, that 2 meter we can write. This is right. 2 meters is wrong. If we are writing the full, then only it is right. The fifth is, the symbols of the prefix are written in the small letters. For example, the symbol for kilo is K and the symbol for kilometer that we are writing is as this. Means KM capital. This is wrong. We have to use the small symbols for writing the prefixes also along with the unit. Now come to the very important topic from this. 1 or 2 questions are sure in exam. This is the conversion of units. Conversion of units means from meter to centimeter, from centimeter to millimeter, kilometer. We are changing the units. These are the conversions of the units, right? Some of the basic conversions are written here, which are mostly used in the numericals. As this is the 6th standard, what are the numericals now? Just like in maths, we are solving the sums. Same as here in the physics also, there are the numericals. Like this is a yellow colored box here. You can see some of the numericals as examples given here. These are the 4 examples. These red colored are the questions and these are the solutions for that numericals. Let's begin it with some of the conversions. First conversion is 1 inch is equals to 2.54 centimeter. Now these conversions you have to learn as it is. These are measured, proved, then these are written here. Second is 1 feet. How we can write 1 foot? That is 12 inches. If I want to represent the inch, 1 slash is used only or 2 slashes? 2 slashes. If I want to write the inch, then 2 slashes are used. If I want to write foot, then 1 slash is used here. For inch, it is 2 slashes. That is for inch. Just like you can see here, 1 inch is equals to this value for the centimeter. Now I'm just telling you these all the conversions. When you apply these all in the examples, in the numerical values, you will automatically here now we are just going to go through from these conversions once. When you will apply these in the examples, in the numericals, you will automatically come to remember in your mind. Okay. So let's discuss the second one. For feet, we are using only 1. We can say feet also, foot also. This is for the foot and only 1 slash is there at 1. For inch, 2 slashes are given. And 1 foot is equals to 12 inches. So we can convert the inches into centimeter also because we know the conversion for centimeter. From inch to centimeter conversion we know. So here, if 1 foot equals to 12 inches, 12 को अगर हम 2.54 से multiply कर देंगे, what we will get? It is the 30.48 value. You can multiply these two numbers and check it in the centimeter. So this is the relation of foot with the inches and with the centimeter also. 1 yard is equals to this length. This you have to remind. And 1 meter equals to 100 centimeter. We all know. We can convert it into inches also, in the feet also. 1 mile equals to this yard and in kilometers it is 1.6 kilometer. Now 1 lb is equals to this value. This is also widely used value. Come to the numerical portion now. Very easy numericals are here. First is a newborn baby weighs this Find her weight in pounds. Weight is given in kg. We have to find in pounds. But we know the relation between the lb and gram only. So what is the first step? Firstly, we have to convert the kg into the grams. After multiplying this kg with the 1000, then it will convert into the gram, because 1 kg is equals to 1000 gram. That's why. So convert the kg into gram, then we can simply apply this conversion very easily to the numerical. Because this is equals to this value now. Here it is very one important thing which you can use. It can avoid your so many mistakes and confusions. Look carefully, bache. 1 kg equals to this value we know. We are changing the kg into the gram, right? And now I want to change the gram into the pound. But I know this relation. 1 lb is equals to 453.6 gram is there. Note one very important point here. The value which I already have, that is in the gram. So I need the gram as alone 1 gram. So this value, that is 453.6 value, will come and will divide this 1 lb. Okay, what is the main point here? If I have the value in gram that I want to convert, then take the conversion always that is equals to 1 only. Gram I have, 1 gram I am taking. Kilogram tha mere paas, then I was taking 1 kg equals to this. The conversion which I wanted to convert, take it as the 1. Take all the other numerical values to the other side. That's why this 453.6, this is in the form of the division here with the 2700. Just now here what to do? Simplify it, place the decimal point, you will get your answer very easily. Okay. In the second example, the distance between two places is given, that is 11.2 miles. We have to express the distance in the kilometers. In mile and kilometer, there is one relation we already know. So, for converting mile into kilometer, 1 mile we already know. 1 mile, no need to convert, just multiply 1.6 with this value and you will get your answer after multiplication. Very easy it is. Next is the height of a man is this given. We have to find the height in the meters. Firstly, we have the relation between the inches and centimeters, not in the meters. We have relation between inch and centimeter. So I have to convert the feet or foot into the inches firstly. I know 1 foot equals to 12 inches, right? So multiply the 5 by 12. 6 is already given in inches. After multiplying, add the 6 in it. 12 5s are 60. 60 plus 6 is 66. You will get the value in the inches. Now 1 inch is equals to 2.54 centimeter. 1 inch equals to 2.54 centimeter, right? So multiply this inch with the centimeters value. You will get this value. 1 meter equals to 100 centimeter, we know. This will come in the form of division because I have centimeter. I need centimeter alone. 100 will come down this way. Multiply these values. Divide with the 100. You will get your answer. Just multiply simply. Division with the 10 and 100 is very easy. No need to divide. Just place the decimal according to how many zeros are there in the denominator. Okay. This is your answer after that. Next, last one example. The area of playground is given in the meter squares. We have to find in the feet square. We know the relation, that is 1 meter square is equals to 3.28 feet. So meter square is here. I need to multiply 1 meter 2 times. Then only I will get the 1 meter square. So if I am multiplying 1 meter 2 times, 3.28 feet also I have to multiply 2 times. After multiplication these two, I'll get this value and in the feet square. Okay. Now this is the for 1 meter square only. This is not the final result. This is for the 1 meter square only and the value is this. I have these many meters. So multiply these many with 10.76 feet square. After multiplication, you will get your answer, the final result. Hope it is clear to everyone. Next is the measurement of length. Measurement of length also we can do in many ways, right? Just like so many physical quantities are available with which we can measure the different physical quantities. Next topic is the measurement of the length. So many things are there. We have many measuring instruments, equipments required which we can use to measure the lengths of the various objects, right? According to the measurement of the object which we want to measure, it depends upon the size of the object mainly, which equipment or the which instrument we are using, which device we are using for measuring, right? This is the feet tape, foot tape, or the measuring tape also we can say. This is the ruler, this is the inch tape, right? We are having any cardboard or any file that I wanted to measure. Now what is they are showing here? This is actually the inch tape, but just assume this is just like the ruler. If it is ruler, you can see here 2 is placed here. It is 2 centimeter. 2 is placed here. Then we are taking the value. Now why we are not taking the 0 at the starting point? Because this may give the error. That's why we are not taking the 0. Why? You can see here in this case the left edge is coinciding or exactly at the mark 2 centimeter on the scale, and the right edge is coinciding with 12.8 centimeter mark. We can just find the difference between these marks. That will give us the length of the file. The question is that why we are not taking the 0 here to coincide? Because after the long use, the ruler, its sides damage and they are not giving us the precise accurate reading. That's why we are using the scale or the ruler from the center. Any of the value we are placing, that we are noting as the first value and the end point as the second value. After taking the difference, we will come to know the original length of the object or of the material. Hope it is clear. Now, most important part, what are the precautions involved in the measuring of the length? 3 precautions are here. First is avoid using the ends of the scale. Why to avoid? Because this may lead to the error. Sometimes the 0 mark on the scale not placed there. It may get erased after the long use. Second is place the scale properly. Place the scale properly means just like you can see here in this figure. In this figure you can see one cardboard is there. We can place scale like this also, but this is the wrong way. This is the correct way. Means place the scale ruler always parallel to the object which we are measuring, only it will give the precise reading. This will change the reading, it will not give us the correct reading. Third is place your eye correctly. You can see here one scale is there. A colored pencil is given here, that is of the red color. You can see the colored pencil's length is up to this mark, which is the solid line. Up to this mark the length is there. Now if we will see the length from here, it will give us the right measurement. If we will move our eye either to left or to the right side, we will not be able to see the correct reading. If our eye will move to this side, it will give one lesser reading. If it will move to that side, it will give 1 point more reading. Just like, let's take one other example. At home in the room, we are having the clock at the wall in the center of the room. And if I want to see the time, if I am looking from the center, I'll able to see the right time. If I'll move myself to one side, thus I can completely see that the hands of the clock will not be at the same position, at the same place. If I'll move to the other side, then also the hand will not give me the same reading. The position of the hand I will see, it will be changing. I'll be able to see the different reading. as compared to this position, this position, this. All the three positions will give me the different readings. You can check this thing also at home. Same is here in the case of the measurement of the pencil with the help of the ruler here. So place your eye correctly, properly in front of the measurement, in front of the scale from where we need to take the reading. Okay. Next is indirect measurement of the length. What is the indirect measurement of length now? Just like we can measure the diameter of the sphere, in maths also we are talking about it. If I want to measure the diameter of the scale, that sphere is of the circular length. I can't measure the diameter of the that sphere properly. So what I have to do, because the ball is circular, it is movable, it can move easily if I try to measure the diameter, right? So we are placing the ball like this in between the two wooden blocks, having the spherical ball in between. Then I am using the ruler. I can note the first reading, which is touching the first edge and the last edge. Both readings I'll take. I'll do the subtraction of the both readings and we'll get the measurement, that is the diameter of the sphere. So this is the way to take the reading of the sphere. Inner edge first reading is this. At the right side, that is this reading. So after getting subtraction, we will get our answer. That is the indirect method of measuring the diameter of the sphere. Hope it is clear. Next is measuring the length of a curve. I am having this type of cup. It is a curved cup, having the side as a curved side. I want to measure the length of this cup or the height of this cup. So what I have to do, I can simply take a thread or the string that I can place here and give it a hold with the finger. I'll leave the thread to downside. We'll see the position here at the bottom also. Then I will remove the thread. This is the, let us say, starting point of the thread. This is the point which is touching the bottom of the cup. So this string or this thread then I will take and I'll keep it near the scale. Then I can easily measure the length of the thread. What the length of the thread will come, that is the length of this cup or the height of this cup. So in this way I can measure the length of the curved surfaces also. Next is measuring the thickness of a coin. How we can measure the thickness of the coin? Just like a coin is very thin, so we can't measure the thickness of one coin. It may be just these two lines it can touch or even less than it, so we can't measure it normally. What is the procedure to measure the thickness of the coin? We are having, just assume, 10 coins. We are placing that 10 coins in the proper one stack in the proper shape by adjusting it properly. Then we are taking the ruler. We are noting the initial first value, second value. After getting subtraction, this is the combined thickness from this place to this place. Of what? This is the combined thickness of the coins. How many coins I placed? I placed 10 coins. This 2.9 centimeter is the thickness of the combined coins. How many coins I placed? 10 coins. I can simply divide this value. We'll come to know the thickness of the one coin. Clear? Next is, the next concept is measuring the thickness of a wire. This concept is also related to the thickness of the coins. As we found the thickness of coins, here we are having any pencil. Just assume pencil is here. Okay. Then I'm taking the wire of which I wanted to measure the thickness. I'm taking some turns or rounds of the wire around the pencil in this way that there is no any gap between the two rounds or two turns. Okay, you can see in the picture all the turns are completely closer to each other. Now we will place the scale near to it. We will measure the starting value, final value. We'll find the difference between it. After getting difference, we must have to know that how many turns we gave to this wire. Just assume these are the 34 turns. the subtracted value, that is this reading, we have to divide it with the how many turns are present in the wire. Then after dividing or simplification, you will get one result that will give you the thickness of the one turn, or we can say it is the diameter of the wire. Wire diameter, just assume this is the wire. This is a thick wire, not the thin one. So this is a circular form wire. So obviously if it is of the circular form, there is a diameter of the wire, right? That is the diameter of the wire. Next is now selection of units. Come to the next topic, how to choose the units. Just assume we are having the difference between the 2 points of room. We are taking the two corners of the room and we are taking the length of it. We are measuring it in the meter. If I will measure it in the kilometers, it is very difficult to show. So what we need to choose, how to choose the unit, a little thought will show that we select a unit in such a way that the numerical value of the measurement will come as simple as possible. Just like some examples are given here. Diameter of ball is this. We could have written this 31 millimeter also, and we can write it as this also. But you can see here the centimeter is the most simplest and the possible way to represent the diameter of the ball. So this is looking very convenient. So this we will use. In this way, we can simply taking an estimation and choosing the unit. Okay. Next is measurement of the area. How to do the measurements of area, this I already explained in the starting. The area is the length into breadth. Two lengths are here which are in the meters, then meter square will come. Everything like same is written here for the various figures, that the unit of area is the unit of length, its square it is, right? Same in the form of the centimeter square, kilometer square also we can write, that is the area actually. Now some of the conversions are given here. If 1 kilometer I know it is equals to 1000 meters, then if I am multiplying 211 kilometers, it will give me, I have to multiply this also 2 times. It will give me this value. Note here, meter square is given, kilometer square is given. Must write the power here. Same like the kilometer, we can easily write it as the meter and centimeter also. This is one of the important conversion now. 1 hectare is equals to 10,000 meters square. It is widely used. One of the numerical is also here related to this. 1 kilometer we have, that is the square field has the measuring side. This we have to find the area. For square meter we know what is the area. It is a side into side. So 1 kilometer into 1 kilometer. In the meters it is this. Why I converted into the meters? Because I know the relation of hectare with the meters, not with the kilometers. Not with the kilometers. That's why I converted the kilometer into meter. This is the value in the meter. Now I am taking this conversion of hectare because it is in the meter already. So this whole zeros will come in the form of division and they are here. Cut the zeros as much possible. You'll get, after cutting 4 zeros, 100 hectares are left, which is the answer of this numerical. Next is measurement of the mass. Now, please listen one thing very carefully. Up to this, we have done the most part of the chapter. Very few and very easy things are left only. If you understood any of the topic really very well, then just please subscribe the channel, like the video and comment below. So let me know that this video is really very helpful for you. So let's begin with the next topic, that is the measurement of the mass. What is mass? That is the how much matter a body is containing, that is the mass. But how we come to know a body is containing this much mass? We are having various instruments for measuring mass also. Here are some of the conversions given which you already know, right? 1 kilogram is equals to 1000 grams. 1 gram is equals to 1000 milligrams. And 1 quintal is equals to 100 kilogram. 1 metric ton. This is mostly used. Sorry. 1 metric ton equals to 1000 kg, right? Or only one zero is more here into this. I can write it as 10 quintal also. Means 1 metric ton is equals to 10 quintal. Alright. Next is simple beam balance. This kind of beam balance I hope you mostly have seen also. This is also known as traju. It is mostly used in the shops. This you can see at the shops, also at the grocery shops. This also with the vegetables vendors and with the at the shops also. These are the commonly used devices and this is known as the simple beam balance. Now how is it working? At this place we are placing the that particular iron material is there. It is of the particular measurement, just like of 1 kg. That iron stones or iron pieces that are in the hexagonal shape. Hexagonal shape means like this, it is having the shape and it is of the proper measurement, just like 1 kg, 2 kg, like this. 50 grams, 500 grams, like this, they are having the proper measurements. All right. So we are placing that iron pieces or the hexagonal shapes here, and in this plate we are placing the material which we wanted to measure and compare with it. Just like we are taking the rice 1 kg, I will place 1 kg stone this here and will place the rice with the help of any scoop or polythene. Then it will give me the correct measurement. The beam, this will balance properly, will become in the horizontal position when both the values become equal, when both the weights become 1 kg each, then this become horizontal. Here also same, we are placing the iron pieces or that one particular standard measurements here. We'll place the other quantity which we wanted to measure. It will become complete horizontal, this line, if I will take it up from this central knob. This is the simple beam balance and this is the working of it. Now come to the next one more thing which is also used for the measurement of the mass. These are some of the balances which are used at the jeweler's shop and these kind of also. Now this is the electronic weighing machine and this is the jeweler's simple beam balance. This beam balance is just acting like the simple beam balance. Nothing is changed in here. And this was used in the traditional era also. It was used very much. They are using the traditional scales, that standard weights they are using. See, it is mentioned here that stones, that pieces are the standard weights because they are having the particular measurement of the weight, that is 1 kg, 2 kg, how much it is. Next other device is the electronic weighing machine. In the electronic weighing machine, we are having the display also, at which they are showing the numbers which are representing how much weight is there of the placed item at the top in this plate. Just like you can see here, one bangle is placed of the gold at this plate. So this will show the weight of it at this displayed corner with the help of the digital numbers. Next is the measurement of the time. What is the measurement of the time? Before doing this, one more use is there of the electronic weighing machine. This is used mostly in the laboratories also, in the physics laboratories also, in the chemistry laboratories also, because sometimes we need the proper amount of the solute, solvent or any mixture. Then at that time we are using the electronic weighing machines to take the certain smaller quantity of the material. Okay. Next is the measurement of the time. We all know that 1 minute equals to 60 seconds and 1 hour is equals to 60 minutes. We can convert it into second by multiplying with the 60. It is 3600 seconds. Same as in one solar day. What is the one solar day? The time period in which the earth is completing the one rotation, that is the one solar day. Clear? So one day is containing 24 hours. We can convert the 24 hours also into the seconds. How? Hours are given. I know the value for 1 hour. Multiply 3600 with 24. You will get this answer. Clear? Next is some of the other things are mentioned here. This is very important part now. The basic standard unit, the SI unit for the time is second, minute, hour, and the solar day. These are some other common units of the time, right? The time in a daily day, we know we are having the cycle of 24 hours, means 12 hours period is there for the day, we can say, and the 12-hour period is for the night. Means sometimes some people are using the 12-hour clock system and some people are using the 24-hour clock system also. When we are using the 12-hour clock system, this is 7:28:05, means 7 hours 28 minutes and 5 seconds, right? In commonly 12-hour system we are using, but if we are using the 24-hour system, that we will study at the next page. Let's study here the 12-hour system. If 12-hour system is there, in the midnight, when 12 o'clock is there, new day is going to start at complete 12 o'clock. What we are saying, it is midnight, time is 12:00 a.m. there. That is midnight time in the 12-hour clock system. Listen again. In the 12-hour clock system, at the midnight, when the day is changing, it's 12 o'clock, it's AM started, new day started. In the morning, we can say that it's 7 a.m. 7 hours after the midnight it is, right? In the evening, it's 7 p.m. That is 7 hours after the noon. Means from the midnight till the 12 noon, till the 12 p.m., we are using AM. We are using AM. After 12 noon, after 7 hours of it, even from this, we are taking the PM as the unit for telling that this is representing the time of day, this is representing the time of the night, because we are having the 12-hour system. So every counting from 1 to 12 will come twice a day. How we come to know this is related to the daytime or night time, evening time, or whichever time? We must have to mention the AM and PM after the time to clarify the confusions. Okay, come to the 24-hour clock now. In the 24-hour clock, this is mostly used in the railways and in the airlines. Okay, in the 24-hour system, here it is not divided into the 12-hour two periods. It is not divided into this, right? It means the time is expressed as the first two numbers are representing the hours and the next two numbers are representing the minutes here. All right, so what are the different ways to write the time in the 24-hour system? Always 4 digits are there. First 2 digits give us the hour value, second 2 next digits are representing the minutes, right? Just assume 1:30 p.m. is there. It is the time after the afternoon. So how we can write it? When we are writing the time after 12 noon, 12 hours already passed of the day, it's one more than it, means we have to add the value in that 12 noon. It is now 13:30 according to 24-hour system. We can write it as this also. We can place 2 dots also. We can place 1 dot also. Here after this, there is no any need to write the AM and PM letter because it is having no any chance of confusion. For example, one more example is given here. 25 minutes past noon means after the noon, 25 minutes past. In the afternoon, 25 minutes past, we can write as 12:25. If it is midnight, new day is just started. No any hour of the day is passed. We will write as 00:25 in this 24-hour system. Okay. One more important thing, time is expressed continuously from 00 means from the midnight to the afternoon. Again come back to the other midnight 1 minute before the next day's midnight. How we will show it? It is 23.59. 24.00 never happens. It is 00.00 when the new day started in the midnight. Hope it is clear. Now, how to do the conversions from 24-hour system to the 12 or from 12 to 24-hour system? Here is the thing. First is to convert a time between 12 midnight and this. What we have to do? We have to add 12 to get the time in AM, because in 12-hour system there is no any time starting from 00. The time is starting from 12. So we will add the 12 into this value. What we will get? We will get 12:59 AM. It is misprinted here. 00 is 12 and okay, yeah, they are just giving the other example. If I'll talk about this, it will give me 12:59 AM. They are taking that 00 is 12 AM and it means 00:55:55 is 12:55 AM. This is also right, but for this specifically, if I want to take the solution of this, it is 12:59. Hope it is clear. Because at the midnight 00 means 12 AM, 59 minutes more, 59 minutes more than it we can write as this with the help of the AM. If 55 minutes are more, that we can write like this. To convert the time between this and this, simply put AM after the time, thus this is the time. How so? Like, I wanted to convert this time to this value, right? They are saying if it is 12 o'clock, simply return it is of the afternoon time, or if it is before the afternoon, it is 1 AM, 2 AM, like 12 in the midnight. After that, the time which is coming till the 12 noon, that no need to do anything, just put the AM behind it. After 12 midnight, if 1 is coming, I can simply put the AM here. Similarly, here also, it's 8:40 in the morning. If it is, then no need to do any addition subtraction, just put the AM after it. Next is convert a time between this to this. 12 noon to 12:59 means from 1 o'clock up to the 1 o'clock. What are the conversions here? Simply put PM after the time. Why? Because 12 is there. 12 hours from 24 are passed. PM part started now. It's 12:59. Just we will put the PM. They are taking the other example. If 12:42 are here, just put the PM. That's it. Now, if it is greater than the 12, 13 से भी greater है, then what we need to do? We have to subtract the 12, because this 21 is coming according to the 24-hour system. We are having 12-hour system. So multiply minus the 12 value, you will get the 9 answer, which is in the form of the PM. Why PM? Because it is after the afternoon. We need to subtract the value to get in the 12 hours. So it is in the PM when we needed to subtract any value. Hope it is clear. Next topic is too easy. That is the time interval. What is the time interval? Your exam is starting at 8:30. 8:30 is the time of the day. For example, the time of the day is what shown by the clock. First period is beginning at 7:50. This is the time period which is referring the particular time of the day. Time interval is that which is the time difference between the two events. First period is starting at this, ending at this. Means difference between these two times is giving me the time interval, that is of the 40 minutes is referring the time interval or the duration of the period. Hope it is clear. So next thing is The next main thing about the time is common clocks and watches measure the time continuously, we know. So we are using the stopwatches. Why we are using the stopwatches? For finding the proper particular time interval in the laboratories mostly. Any experiment is going on, in how much time interval, that we are measuring with the help of the stopwatch. Okay. Next is very easiest topic, the measurement of the temperature. Temperature we can measure with the help of the different scales of measuring temperature. Two scales are drawn here. One is the Celsius scale, second is the Fahrenheit scale. One is the clinical thermometer, second is the laboratory thermometer. Clinical thermometer is used for the human beings for finding their body temperature and so on, right? The laboratory thermometer is used for the laboratory things, for doing the various experiments, to check the temperature of the solution, to check the hotness of the liquid. So that in that case, the laboratory thermometer is used. Now, how it is made and what are the different factors which are present here, which are the different parts present in these scales, that we will study. Firstly, come to the Celsius and the Fahrenheit scale, which is available in the both of the thermometers. This clinical thermometer also, laboratory thermometer also. The clinical thermometer is in the degree Fahrenheit mostly, but at the other side it is given in the Celsius also. Otherwise, we can convert by using one formula that you will learn in the higher classes. This laboratory thermometer is mostly giving the reading in the degree Celsius. Degree Celsius we can convert into Fahrenheit also. Okay, this degree Celsius we can convert into Fahrenheit also. Next is Celsius thermometer is there, Fahrenheit thermometer is there. Celsius thermometer is having the lowest point 0 degrees Celsius, highest point 100 degrees Celsius, which is the freezing point and the boiling point of water. That is in the degree Celsius. The SI unit of temperature is Kelvin, representing with the capital symbol K. If I am writing the full unit, we have to write the small letters. Why? Because we did the rules for the writing units, right? Just away from the Kelvin, two scales are widely used, degree Celsius, degree Fahrenheit. Lower point for the degree scale Celsius is 0 degree. Highest point 100 degrees Celsius, which is the boiling point of water. For Fahrenheit temperature, it is minus 10 degree here. For this, it is 32 degree Fahrenheit and its highest is 212 degree Fahrenheit. Okay. Now, the next is how the thermometers, which are the clinical and the laboratory thermometer, are constructed, how they are different from one another. Firstly, you can see here also there is a bulb here present, which is connected with the long cylindrical length, which is known as the stem. You can see here in this picture, here thermometer is present, which is having the bulb here, having the long rod. This kind of tube is here, which is known as the stem of it, and the bulb holds the mercury inside it, which is connected to the thin tube inside the stem. This thin tube, you can see, this is the tube inside the stem, which is also known as the bore. Now, when the bulb is heated, the mercury is expands to the bore and it looks like the very thin shining thread here in between. Like here you can see it is up to this mark. So this is the mercury. This rising thing material inside is the mercury, which is rising in the bore, and bore is present in the stem. Bore is very thin tube inside the stem. Hope it is clear. Then the temperature scale is marked on the stem. You can see the temperature scale is here marked on the stem. From here we can easily measure the temperature or the thermometer reading from the marks of the mercury thread. Hope it is clear. Then the next is there are one important difference between the clinical and laboratory thermometer. What is the difference here? Near the bulb of the clinical thermometer, a small band is there. You can see this band is present here. The arrow is marked only to the clinical thermometer. This kink's arrow is not marked to the laboratory thermometer. Why? Because this band is only present in the clinical thermometer, and this is because of the kink present here in the clinical thermometer. What is the benefit of the kink? Because it helps to preserve the mercury to that same level for certain time, so that till the time we can take the reading. If any person is taking the thermometer inside the mouth for measuring the fever, for measuring the body temperature, till the time the person is keeping it outside, taking it to the outside, so that the mercury level will not go down. That's why there is a kink present here which avoid the mercury to come back to the original position again. That's why this kink is present. Okay, and this is measuring the temperatures, various temperatures. The temperature of the human body is in the Fahrenheit. It is 98.6 degree Fahrenheit. In the degree Celsius it is 37 degree Celsius. Hope it is clear. Then this is used for checking the boiling of the water also, and for various things it is used for checking. Laboratory thermometers also reads the atmospheric temperature. When it is not in the use, we have to preserve it properly. Second thing is, this laboratory thermometer is used how? We just putting direct into the solution whose we want to measure the temperature, or we can use one clamp. Clamp means this is a kind of, this kind of table is there, this rod is there present having one hand here. With the help of any clip is there present, with the help of that clip we can stand the thermometer here. Just assume here the beaker is placed, we can measure the temperature. How and when to measure the temperature? When this mercury level stop increasing, stabilize at one point, we will take the reading without taking the thermometer outside, because in the laboratory thermometer there is no any kink present. If we take the thermometer outside immediately, or it will give the wrong reading of the measurement of the measuring temperature. So read the reading there only, then only take the thermometer outside in the case of the laboratory cases. Next come to the approximation. What is approximation now? Very easy topic. Approximation and estimation you are doing in the mathematics also. What in the case of mathematics, we are having the numbers or the values. Now how in the case of maths you are doing it? Just like you are rounding off the numbers near to the 10, 100 to take the approximate estimated value, right? In the case of real life also, if any salesman is selling the jeans and your wrist size without actually measuring your wrist, just taking the assumption, and the cook is adding the spices like salt and sugar without actually doing the actual proper measurement with the help of the weighing machine, just we are saying the normally with the help of the estimation we are putting the spices into the food material, like okay. Then the taxi driver is also just telling us sometimes the approximation time it will take to reach to the destination. That all are coming under the approximation and estimation, means just the estimated value, not the actual thing. Now what is the benefit of it? It saves the time and saves the trouble of measuring. It just gives the idea, it saves the time of the measurement. But the main thing is, the main disadvantage is it may be inaccurate also, which later may waste a lot of time if we will just try to find out a shortcut and thinking that it will take the lesser time, but without the proper measurement or without knowing properly about the place, it may give the inaccurate value also. So actual measurement are made when accuracy is important. For example, timing of the race, buying things by weight, then at that places the accuracy is important. So people are measuring with the help of the stopwatch, with the help of the weighing machines. Okay. Next is the averages. Average, this value is also related to your maths. What is the average? Average means just like there are 20 students in the class. 20 students are getting like 19, 18, 16, 12, 20, 25. Like this 20 students are getting the marks. So sum of all the values plus of all these 20 students marks divide by how many students I said? Number of values, 20 values. You will get your average value. Average value it means, what is the average value? It is giving the approximation that the data, its major part is lying near to this value. Okay, that is the estimation value. For example, The average of the group similar numbers is a number that gives a general idea of the value of the most of the numbers in the group. For example, when we say that the batting average of the batsman is 40, we mean that he bats usually scores that close to the 40 runs. That's why his batting average is 40. Average is 40, right? So this is very important formula. Average is equals to sum of values divided by number of values. For the numericals also, this is very important. Next was one numerical given here. Annual rainfall in one town is measured from this to this year. This was the recorded values, and this was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 values are given here. Because 10 values are here, so number of values are 10. We have to divide by 10. After adding all these values, we are getting to 928 as the answer. Division of 10 100,000 is very easy. 1 0 is here. So place the decimal after the 1 place. This is the answer you will get. Same, some of the things are written here. Along with the, this is the example, very best example for measuring the average. Along with this, you can do one activity, that is you can do in the class. Just place your right hand's 3 fingers near to your waist. You can here see that your pulse is moving on. You can experience it very easily. When your pulse is moving on, you have to note that in 1 minute, how much in 1 minute means in the 60 seconds, how many times your pulse is moving, that is your pulse rate. So various different students, just like all students of the class are recording the pulse rate in the 1 second, all are getting some different up and down values. So after adding all that values, you will get the lowest and the highest values denote the range of the pulse. After getting all the values, you can find the average also. What is the range now? The difference between the highest and the lowest value is the range. Okay. Last topic of the chapter, very easy topic. This is standard weights and measurements. As I told you in the case of the simple weighing machines, what I told you there, the hexagonal shaped iron stones standard weights are used for measuring the. So how can we tell that this is related to the standard scale now? In the case of the meter scale, let's come to this. How we can recognize that this meter scale is the standard one? Firstly, the meter scale used for the correct measurement of length is shown as it is in the figure. It is shown like this. What are the differences here? What are the main things to be noted here? There are the 2 arrow marks at the ends, at the both of the 2 ends of the scale, and one stamp is there of the department at the back side, at the reverse side of the meter scale. The graduation marks, these marks are represented by the 10 centimeters apart, and some smaller, these divisions are here which are of the millimeter. Next is the standard weights. The standard weights, these are made of the metal and weights of the particular amount, means of 1 kg, 2 kg, 500 gram, 100 gram, like this. The value of the weight is marked at the top of the surface, and the heavier standard weights are made of the iron in the hexagonal shape. Just like as I said you, it is of the hexagonal shape. The lighter ones are made of the brass and they are circular in shape, which are the smaller ones. Next is each iron weight has a hole at the bottom. Some lead, a metal, is poured into this hole to get the exact weight, and there is a stamp at that lead of the department. Now, what are the dishonesty the person can do in the measurements? The first is the metal scale used by the trader may be of the less than the 1 meter. So check the arrow mark and the stamp to make sure that the scale is authentic, means proper, it is standard. The metal weights used by the trader by the weight may be the less than the proper value. In the incorrect weight, in a correct weight, there should be the lead in the hole, and the proper stamp on the lead is there at the back side of these iron metals. Balances may have the following defects. This is very important one. 3 defects may be happen there. First is beam may fixed rigidly to the handle so that suspend the balance. Beam balance जो है, this one is fixed so that it will not move to the undesired place. Only it will move up to the point we want, only till that point. So it may fix it rigidly so that it will not be suspended completely. It will not give the proper measurement. That's why. Next is the two arms of the beam may be unequal. Means if this arm is smaller or greater, larger, then also it will affect the balance of the beam. Means it will tilt to one side very faster. This will give the unbalanced beam. Beam will balance like this way also, but there is the not unequal weight in both the pans. There is unequal weight in both the pans. Third point is the pans may be unequal in weight. If the pans are unequal in weight, how will be this stable? So we have to put to one side the more amount, then only it will become stable. So this is a kind of defect. That's why. Next is some traders may use the non-standard balances. The beam of the standard balance is stamped on the both sides. These beams are also stamped on the both sides if it is really belonging to the standard balance. So with this, your chapter explanation is over now. Nextly, let's see some of the points to remember are here. These you must have to prepare for the exam as for the internals. The next thing is short question answers are there from the exercise. Long question answers are there. And the objective type questions are there. The objective type questions, blanks, true, false, these are very important. Especially the numericals of this chapter are also too much important. So if you want the exercise also of this chapter, do comment. I will make the video on it also. If you reached till here, you are really a brilliant student and honest with yourself, with your study. All the very best for your exams. May you score full marks. Have a good day, good exams. Subscribe my channel. Don't forget to press the bell icon. Thank you for watching.